Welcome to the next video tutorial of Open Commissioning. This video is about connecting an ABB Robot Studio controller to our simulation model running in TwinCAD and Unity, so we can use the movements and the inputs and outputs of the robot controller inside our simulation here. So we see here right now, this is already running. On the left here is the Robot Studio controller performing the program. And on the right-hand side here is our Unity model. And we see all the movements are mirrored exactly here. It is performing the program and everything is connected through the Open Commissioning Assistant and TwinCAD. But first, let's have a closer look at how this is working. So let me give you a quick overview of all the different components that are working together here. So we see here 3 different areas. The first one is the digital twin, the model itself, which consists of the behavior models running in TwinCAD, connected to Unity, where the physical simulation and visualization is performed. The connections between them is done automatically as part of Open Commissioning. The second area is Assistant, that is used to connect third-party systems to the digital twin. In this case, we are using the Robot Studio plugin to connect to a Robot Studio controller, cyclically exchange data with it, make this data available to TwinCAD, to the behavior models of the digital twin in a global variable list. So the plugin and the assistant have 2 tasks: receiving and sending data from into the robot controller and making this data, the inputs and outputs and access values and so on, available to TwinCAD for the behavior model. The data in the global variable list is then mapped to the behavior model of the robot, which completes the chain. So the data from the Robot Studio controller can flow to the model. So here you can see all those components in action. So we have here the assistant connected to the TwinCAD solution. We have Robot Studio plugin running, connected to the controller, receiving the data, making it available to TwinCAD using the variable list. We can see this here. And we can see the access values changing, the inputs and outputs, and then in Unity see the robot performing the movement, also working with the inputs and outputs. Okay, so let's start modeling this from scratch. So let's start at the beginning. So what you need is a Robot Studio project with running controller and a program. So here I just had a little example program that moves the robot a little bit. Then you need, of course, Unity installed with the Open Commissioning package. How you can do this is described in the GitHub or in other tutorials. Then you need to have the Open Commissioning Assistant on your system. So just download it and put it in your folder. And also you need to have TwinCAD installed with the Open Commissioning library. And the goal is that we connect this Robot Studio controller with the assistant. So the assistant can get values from this and make it available in TwinCAD. And from there, we can send the values Unity to the robot model there. Okay, so let's get started. The first thing we need is to install the Robot Studio plugin for the assistant. So we can head over to the GitHub repository of the Assistant Robot Studio plugin, go to Releases and download the zip file and save it to the same directory where the assistant application is located at. So we unzip it And this is basically the installation process. So we just have to unpack the contents of the release folder to the same directory of the assistant. And from now on, this is available for the assistant to connect to the Robot Studio. Okay, so let's open the assistant and create a new solution from scratch. Specify a name. Let's call it Robot Tutorial and wait for the assistant to finish creating it and open it. Okay, the solution is created and TwinCut is open. At the moment it is in running, so we have to restart it in config mode to add the plugin. So we add the plugin with the plus button here, add plugin instance, and Robot Studio is already selected. It's the only one we have installed, so this is the one that is selected. Let's call it Robot 1. So this is the instance name that will appear in the assistant and also after generating the global variable list in TwinCut will have the same name. Auto start means that it is starting and stopping with TwinCut, so we keep this checked. The controller name needs to be the same controller name as specified in the Robot Studio project. So in this case, it is called IRB underscore 6620. IRB. We have 6 axes on this robot, so we specify the axis number here. Cycle time of 50 milliseconds is okay. And we also need to specify the Robot Studio solution that the controller is running in. So let's select it. So the plugin goes through the Robot Studio solution and checks all the required inputs and outputs and makes them available as a GVL in the TwinCut solution. So the configuration is done. Let's click Apply, save Robot 1. And it is saved. We see that the instance here is now appeared. And also we saw that the global variable list for this plugin has been automatically created in the solution. The global variable list is here, and also the structures that include the project specific inputs and outputs. So in this case, we have a few input bits and a few output bits. But this depends on the solution provided here. Okay. So when we activate the configuration, starting the TwinCut system in run mode, we see that when the system started in run mode, the Robot Studio plugin also connected. You see this here as a log that it is successfully connected to the robot controller, which is running here. And when we look inside TwinCut, we see all the inputs and outputs of the robot controller available in TwinCut. So also here we see the axis values 1 to 6. This is so the pose of the robot here at the moment corresponds to those axis values. Then if the robot starts moving, so let's start the simulation here inside Robot Studio, we see the axis values are changing. Yeah, according to the movement that the robot is performing. So now we achieved that Robot Studio is connected to TwinCut using the Robot Studio plugin in the assistant. We are receiving the relevant data, And now we need to model the robot inside Unity to use these values. Okay, so here I have basically an empty Unity scene with the open commissioning package installed. The first thing we are going to create is an empty game object. Let's call it project. And to this, we're going to add the ADS client component, change the port so it connects to the PLC project. And under this, we are now adding the robot. Okay, so what I added here is basically the geometry of the robot that you can get from the ABB website. And I structured it in a certain way in the game hierarchy structure so that the game objects here correspond basically to the kinematic chain of the real robot. So every game object called joint is at the same exact position as the rotation axis of the robot would be. So for example, the first one is located here and rotates around this axis. The second one is located here, and so on, and they all correspond to the rotation axis of the robot. So this hierarchy matches the kinematic chain of the real robot. This only contains geometry at the moment, and now we need to add the open commissioning components that enable us to connect to TwinCAD to control this. So at the first node here, called robot, I will add the component called robot. So this is part of the Unity package and enables us to receive values from TwinCAD and control certain access with this. We can see here some configurations. Here the values will appear when we are running the simulation. But first we have to configure this object and reference all the axes that this robot has. So in total, we have 6 different axes, and we now need to define those axes. So at the moment, as I said, this is only geometry, and to add the axis component to every joint, we can select each joint object and add the axis component. And we have to specify the direction. In this case, the rotation axis of every joint here is corresponding to the y-axis of the game objects. So we specify the y direction here. Also set the type, which is a rotation. So now we see every game object that models a joint has the axis component added to it. So this can rotate around its y-axis to model the movement of the robot. So now we can reference those components to the robot component simply by dragging them into the fields here. So the first joint is the element 0 in the axis references. The second one is element 1 and so on. And we drag them all in. They automatically get referenced because they have the axis component added to it. Oh, I already done that. Okay. Joint 4, 5, and 6. Okay, so now every axis is referenced to the robot component. We also need to specify a factor. So this value gets multiplied with the value we are getting from the controller and can be used to model like gear ratios or also flip the direction of the axis if necessary. But for now, we set it all to 1. So the the value we receive from the controller directly goes unchanged to the axis. Okay, so now that the component is modeled and we have all the required references, we need to create the behavior model for this in TwinCut, so we can connect the values we're receiving from the controller to the behavior model, so they can control the axis in the simulation. So to do that, we have to restart the TwinCut system in config mode and go to the object that contains the client script and click Update TwinCut project. We see that the project tree was sent to the assistant. The assistant updated the project here in TwinCut, and we see that in the main program, a new variable with the function block here was added, which is the behavior model for this robot. Okay, so now we have the robot behavior model available here in TwinCut. What we now have to do is connect this robot behavior model with the values we are receiving from the Robot Studio controller. And we do this by calling a specific function of that behavior model at the beginning in init run of the main program. So we go here and add the line robot connect joints. And it takes two parameters. The first argument is the access array of the GVL for the robot, and the number joints is 6. So this maps the access outputs of the Robot Studio GVL to the robot behavior model, which enables us to control the robot inside Unity. Okay, so now we activate the configuration and restart TwinCut in run mode. So it is running. Now we start Unity in game mode. And we already see the robot has moved. So we see here now, when we look into the robot component, that we are receiving values. Those are exactly the ones we are receiving from the robot controller. So now when we press play in the simulation in Robot Studio, we now see that when the robot in Robot Studio is moving, the values are also received by Unity. One thing that is obvious is that some axes here are switched. So the direction of the axis modeled here is not the same as in Robot Studio. This is a very quick fix. We just have to switch the direction by using the factor here. So in this case, I tested this before. We have to switch the following axis. So it's the first one, and the fourth one, and the last one. And now when we play again, we see the robot behaves exactly as modeled here in Robot Studio. So now when we start the simulation in Robot Studio, the movement is mirrored exactly in Unity. Okay, so this is basically complete now. We successfully connected the Robot Studio controller using the assistant plugin to the simulation. We were mapping the access values to visualize and simulate the movement of the robot in Unity. Of course, as you saw in the beginning, you also have access to all the other inputs and outputs of the robot interface, so you can use them to control any attachments or tools that are controlled by this interface as well. So you can try this out for yourself. Let us know how this is working for you. And we thank you for watching, and we will see you next time. Thank you.